Hello students, welcome to this lecture One Triangles. In this lecture, we will discuss criteria for similarity of triangles and then we'll discuss summary of this chapter. Okay, so let's get started. So in the previous section, we stated that two triangles are similar. Okay, so there we have studied two triangles are similar if their corresponding angles are equal, and second, their corresponding side are in the same ratio or proportion. Okay, that is, in triangle ABC and triangle DEF, if angle they are similar, if angle A this is equal to angle D, okay, angle A this is equal to angle D, angle B this is equal to angle E, and angle C this is equal to angle F. Okay, and the ratio AB over DE, AB over DE, this is equal to BC over EF, and this is equal to CA over FD. Okay, that means their corresponding angles are equal and their corresponding sides are also in same ratio. Okay, then these two triangles ABC and DEF are called similar. Okay, so here in this lecture we will discuss first criteria for similarity of triangles. So here you can see that A corresponds to D, E corresponds to D, and B corresponds to E, and C corresponds to F. Okay, so symbolically if we write the similarity of these two triangles, triangle ABC and triangle DEF, as by this symbol. Okay, so triangle ABC is similar to triangle DEF. Okay, and we read it as triangle ABC is similar to triangle DEF, and the symbol this symbol stands for is similar to. Okay, so this symbol stands for is similar to. So here we recall that you have used the symbol this. Okay, so we use this symbol for is congruent to in class 9th. So in class 9 you use this symbol for is congruent to. When we have two triangle ABC and triangle DEF, they are congruent to each other, then we use that case triangle ABC. This is congruent to triangle DFE. Okay, so this symbol we used for is congruent to. Okay, and we have studied in our previous lecture, if two triangles are congruent to, then they are similar, but converse is not true. Okay, so converse need not be true. That means if two triangles is similar to, then the two triangles is not congruent to, need not be they are congruent. Okay, so it must be noted that as done in the case of congruency of two triangles, and the similarity of two triangles should also be expressed symbolically using correct correspondence of their vertices. Okay, so for example, you can take for the triangles ABC and triangle DEF of figure 6.22. So here in this figure 6.22, okay, from this figure, so in this figure this triangle ABC and triangle DEF, we cannot write triangle ABC is equivalent to triangle EDF, or triangle ABC is equivalent to triangle FED. However, we can write triangle BAC, this is similar to triangle EDF. Okay, so we cannot write triangle ABC, this is similar to triangle EDF, or triangle ABC is similar to triangle FET. However, we can write triangle BAC, this is similar to triangle EDF. Okay, so this triangle is similar to this triangle, and here this symbol, tilde symbol, is used for is similar to. Okay, so now a natural question arises for checking the similarity of two triangles. The triangle ABC and triangle DEF, should we always look for the equality relations of their corresponding angles. Okay, so as given the figure in previous slide, here we have given two triangle ABC and DEF. That case, these two triangles are said to be similar to each other if their corresponding angles are equal and their corresponding sides are in same ratio. Okay, so we always look for all the equality relations of their corresponding angles. Angle A, this is equal to angle D, and angle B, this is equal to angle E, and angle C, this is equal to angle F. And all the equality relations of the ratios of their corresponding sides is ED over DE, this is equal to BC over EF, and this is equal to CA over FD. Okay, so let us examine. You may recall that in class 9th, you have obtained some criteria for congruency of two triangles involving only three pairs of corresponding parts, okay, or elements of the two triangles. So in our previous class, in our class 9th, there we have studied the criteria for congruency of two triangles, okay, that involving only three pairs of corresponding parts or elements of the two triangles. Okay. So here also let us make an attempt to arrive at certain criteria for similarity of triangles, similarity of two triangles, that involving relationship between less number of pairs of corresponding parts of the two triangles, okay, and instead of all the 6 pairs of corresponding parts. So let us make an attempt to arrive at certain criteria for similarity of two triangles. So theorem 6.3, here we have given this figure. Okay, this is our triangle ABC and this is our triangle DEF. So if in two triangles corresponding angles are equal, okay, then their corresponding sides are in the same ratio or proportion, and hence the two triangles are similar. Okay, so this theorem 6.3 stated to us, if in two triangles, suppose we have these two triangles ABC and DEF, and their corresponding angles are equal, and it is automatically implies that their corresponding sides are in the same ratio or proportional, okay, and hence these two triangles are similar. So this criterion is referred to as the angle criteria of similarity of two triangles, as similar angle for congruency of two triangles. Okay, so here this criteria is referred to as the AAA, AAA, okay, and AAA criteria of similarity of two triangles. And this theorem can be proved by taking two triangles ABC and DEF, okay, such that angle A, this is equal to angle D, and angle B, this is equal to angle E, and angle C is equal to angle F. Okay, so you can see the figure 6.24 that is shown in this side, okay, this slide. So here this triangle and this triangle, here actually their corresponding angles are equal. That means angle A, this is equal to angle D, angle B, this is equal to angle E, and angle C is equal to angle F. Okay, so now cut DP, this is equal to AB, and DQ, this is equal to AC, and join PQ. Okay, so here we do this thing. DP, this is equal to DP, this is equal to AB, and this DQ, this is equal to AC. And from triangle ABC, actually we cut DP at P and DQ at Q. Okay, so here these two triangle ABC and triangle DPQ are actually congruent to each other. Why this? Because angle. Okay, so their corresponding angles are equal. This gives us angle B, this is equal to angle P, this is equal to angle E, and PQ, this is parallel to EF. How? This is our, actually these are equal. Okay, so these are equal angle. So this line PQ, this is parallel to EF. Okay, so therefore by the basic proportion theorem, here we get dP over PA, P, this is your dQ over QF. Okay, so by the basic proportion theorem we get this relation. Okay, and that is AB over DA, this is equal to AC over DF. And similarly AB over DE, this is equal to BC over EF, and so AB over DE, this is equal to BC over EF, this is equal to AC over DF. Okay, so we get this AB over DE, this is equal to AC over DF. So it proved to prove us, if in two triangles corresponding angles are equal, then their corresponding sides in the same ratio. Okay, so their corresponding side AB over DE is equal to AC over DF, and this is equal to BC over EF. And this criteria is referred to as the AA criteria of similarity of two triangles. Okay, so now let us make a remark. So in this remark, it said to us, if two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property of a triangle, their third angles will also be equal. Okay, so you have already studied about angle sum property of a triangle in your class 9. Okay, so if two angles of a triangle are respectively equal to two angles of another triangle, then by the angle sum property here of a triangle, their third angles will also be equal. Okay, so therefore angle similarity criteria can also be stated as follows: if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. Okay, so this is also a criteria of similarity of two triangles. So here this may be referred to as the angle similarity criteria for two triangles. Okay, so this criteria is referred to as AA similarity criteria of two triangles. Okay, so from this result here, from this criteria, angle here, this theorem said to us, if corresponding angles of two triangles are equal, then their corresponding sides are also in same ratio. And here in this remark, here if two angles of a triangle are respectively equal to the two angles of the other triangle, okay, another triangle, then by the angle sum property, here this property is very important, angle sum property of a triangle, their third angles will also be okay, and therefore angle similarity criteria can also be stated as follows: if two angles of one triangle are respectively equal to angles of another triangle, then the two triangles are similar, and this may be referred to as the AA similarity criteria for two triangles. Okay, now you have seen above that if the three angles of one triangle are respectively equal to the three angles of another triangle, then their corresponding sides are proportional, that is in the same ratio. Okay, so this is very important criteria for proving two triangles are similar triangles. Okay, so if you can show the three angles of one triangle are equal to the three angles of the another triangle, then their corresponding sides are proportional, that means they are similar triangle. Okay, so what about the converse of the statement? That is, if their corresponding sides are in the same ratio, then it implies that their corresponding angles are also equal. Okay, that means if three sides, ratio of their corresponding sides, their corresponding sides are in the same ratio, then it implies the three angles of the one triangle are respectively equal to the three angles of the another triangle. Okay, so you can say in other words, if the sides of a triangle are respectively proportional to the sides of the another triangle, so is it true that their corresponding angles are equal? Okay, so here we have theorem 6.4. So if in two triangles, sides of one triangle are proportional to, that is in the same ratio of the sides of the another triangle, then their corresponding angles are equal, and hence the two triangles are similar. Okay, so this theorem actually the converse of the theorem 6.3. Okay, so in 6.3 it stated to us, if in two triangles, three angles of one triangle are respectively equal to three angles of another triangle, then their corresponding sides are in same ratio, that is they are in proportional. So here in this theorem it stated to us that if in two triangles, sides of one triangle are proportional to the sides of the another triangle, then their corresponding angles are equal. And if we have corresponding angles are equal and their corresponding sides are in same ratio, that is they are in proportional, then the two triangles are similar. Okay, so from this theorem here it implies to us that then the two triangles are similar triangle, and this criteria is referred to as the side similarity criteria for two triangles. Okay, so this is actually similar as congruency of two triangles. Okay, so there we have also criteria of angle, and we have criteria side. Okay, so here we also studied these two criteria, angle similarity criteria of two triangles, and side similarity criteria for two triangles. Okay, so this theorem can be proved by taking two triangles. So by taking these two triangles, suppose we can prove this theorem. So here we take triangle ABC and triangle DEF, such that the ratio AB over DE, this is equal to BC over EF, this is equal to AC over DF. Okay, so their corresponding sides are in same ratio, and this ratio basically less than 1. And now cut DP, this is equal to AB, and DQ, this is equal to AC, and join P and Q. Okay, so it can be seen that DP, this is actually equal to AB, and DQ is equal to AC. Then DP over PE, this is equal to DQ over QF. Okay, so now by converse of the basic proportional theorem, it implies us that PQ, this is actually parallel to the side EF. Okay, so these two ratios are equal, and here this line segment PQ is parallel to the side EF. And so here angle Phi, this is equal to angle E, and angle Q, this is equal to angle F. Okay, so therefore DP over DE, this is equal to DQ over DF, and this is equal to PQ over EF. Okay, so by basically here use the previous theorem. If three angles of one triangle are respectively equal to the three angles of another triangle, then their corresponding sides are in same ratio. Okay, so here we have given this triangle, angle P, this is equal to angle E, and angle Q is equal to angle F, and therefore this ratio are equal in same ratio. Okay, so the dp over d, this is equal to dq over df, and this is equal to pq over ef. And so here dp over de, this is equal to dq over df, and this is equal to pc over ef. Okay, why this is happen? Because pq over ef, pq actually equal to bc. Okay, so bc, this is equal to pq, and thus triangle abc is congruent to triangle dpq. Okay, for these two triangles, two angles are equal. Okay, their corresponding two angles are equal, and one side pc, this is equal to pq. Okay, so by angle side angle criteria, these two triangles are actually congruent to each other. Okay, so therefore angle A, this is equal to angle D, angle B, this is equal to angle E, and angle C is equal to angle F. Okay, since they are congruent, that is their corresponding angles are equal. And now here remark, we have remark. So in this remark, it said to us, you may recall that either of two conditions, namely corresponding angles are equal and corresponding sides are in the same ratio, is not sufficient for two polygons to be similar. Okay, so here the two conditions, namely corresponding angles are equal and corresponding sides are in the same ratio, is not sufficient for the two polygons to be similar. However, on the basis of the theorem 6.3 and 6.4, you can now say that in case of similarity of two triangles, it is not necessary to check both the condition, as one condition implies the other condition. Okay, so now for showing two triangles are similar, here if we check one of the any one condition, then automatically one condition will imply the another condition. That means if we have given two triangles, okay, and their corresponding angles are equal, then it implies by the theorem 6.3 their corresponding sides are in same ratio. Okay, and therefore they are similar. And from the theorem 6.4, here actually it implies that if their corresponding sides are in same ratio, then their corresponding angles are equal. Okay, so from basis of theorems 6.3 and 6.4, we can now easily say that in case of similarity of the two triangles, it is not necessary to check both the conditions. Okay, actually one conditions implies to other conditions. So let us now recall the various criteria for congruency of two triangles that actually we have learned in class 9. Okay, so you may observe that side similarity criteria can be compared with the side congruency criteria, and this suggests us to look for a similarity criteria comparable to side congruency criteria of triangles. Okay, so here we have studied two criteria for similarity of triangles. One is angle similarity criteria, and other is side similarity criteria. Okay, so we have studied side congruency criteria of triangles. Okay, so if we compare with this, so here we get this theorem 6.5. So if one angle of a triangle, this is actually equal to one angle of the other triangle. Okay, and the sides including these angles are proportional, and then two triangles are similar. So here we have given one angle of the triangle is equal to one angle of the other triangle, and the sides including these angles are proportional. Okay, and then it implies to us that two triangles are similar. Okay, so this criteria is referred to as the side similarity criteria for two triangles. So here, as before, this theorem can be proved by taking two triangles. Here we taking these two triangles ABC and DEF such that this ratio AB over D, this is equal to AC over DF. Okay, and these two ratios are basically less than 1. And here angle A, this is equal to angle D. And here we cut DP as this is equal to AB, and cut DQ, this is equal to AC. Okay, and now we join P and Q, and now here this line segment PQ is parallel to EF, and from this here these two triangle ABC and triangle DPQ are basically congruent to each other. Okay, so they are congruent to each other. So angle A, this is equal to angle D, and angle B, this is equal to angle P, and angle C, this is equal to angle Q. Okay, so therefore triangle ABC is similar to triangle DEF. Okay, so we now take some example to illustrate the use of these criteria. So here we take this example. Okay, so here we have given this figure 6.29. So here if PQ this is parallel to RS, and here we have to prove that POQ this is similar to SOR. Okay, so let us prove it. So here we have given PQ this is similar to PQ this is parallel to RS. Okay, so as alternate angles, here angle P this is equal to angle S. Okay, and angle Q this is equal to angle R, since they are alternate angles of this triangle. So also angle POQ this is equal to angle S over, as they are vertically opposite angles. Okay, so therefore triangle POQ this is similar to triangle SOR. Here we use angle similarity criteria. Okay, and here in next example, here we have job figure 6.30, and here we have to find angle Phi. Okay, So we have given some values of, here we have given side, the length of this side, and this side, and here we have given wall length of this sides of this triangle. Okay, and here we have given angle A, this is equal to 80 degree, angle B, this is equal to 60 degree. Okay, and we need to find angle P. So here we use our previous theorem that we have studied in our previous slide. Okay, so here in triangle ABC and triangle PQR, here this ratio AB and RQ, this is equal to 3.8 divided by 7.6, and this is equal to 1 by 2. Okay, and here BC over QP, this is equal to 6 by 2, 12, and this is equal to 1 by 2, and here CA over PR, this is equal to 1 by 2 also. So that is AB over RQ, this is equal to BC over QP, and this is equal to CA over PR. Okay, so by the SSS similarity of two triangles, it implies triangle ABC is similar to triangle RQP. So therefore angle C, this is equal to angle P, since they are corresponding angles of similar triangles. Okay, but angle C, this is equal to 180 degree minus angle A minus angle B. This is actually by angle sum property. Okay, and this is equal to 180 degree minus 80 degree minus 60 degree, this is equal to 40 degree. So angle P, this is equal to 40 degree. I stop here this lecture. Thank you very much to all of you.